In this experiment, I'm going to try to dissolve some gold using muriatic acid or hydrochloric acid and bleach. And then I'm going to precipitate the pure gold with plant food. In the beaker is some pure gold that was inquarted with sterling silver. It's lightly boiling in dilute nitric acid. Okay, I begin the experiment by pouring off the hot acid. I'll save this acid. It's still good and can be used to dissolve metals in the future. Next, I'll rinse the gold with a little distilled water. Pour that off into my silver jar. Just heat it up for a little while. Okay, the gold's been heating on low heat for about 10 minutes now. You gotta watch it so you don't start boiling that water or you'll bump gold out of the container. I'll go ahead and pour it into my silver jar now. Okay, now I'm going to go ahead and add some hydrochloric acid. There's probably going to be a little bit of residual nitric in there, and we'll start to see a reaction as soon as I add the hydrochloric acid. About 300 ml. I put the hydrochloric acid and gold mixture onto the heat, and then I turn the heat down on low. Now I'm going to measure out about 200 ml of bleach and start adding it to the mixture. Okay, I've added about 100 ml of bleach, and this is about 30 minutes into the reaction. I can tell by the color that I've got gold going into solution. This is a piece of filter paper that I cut up. Just dip it in the solution and put some stannous chloride test solution on it. And that black stain right there proves that I got gold in solution. I'll go ahead and add the rest of the bleach. Move the experiment out here to a hot plate stir. Add a stir bar. See if I can help things along by stirring the mixture as I add the bleach. I'm going to keep the heat on pretty low, about number 3 on the hot plate stir there. Okay, the thermometer here says that the solution, or the beaker anyway, is about what, 178, 179 degrees. I'm going to go ahead and pour some of this bleach in there, try to get the last little bit in so we can get this over with. can see that or not. Here it's about 15 minutes later, about 3 hours 45 minutes into the reaction. I'm going to go ahead and add a little bit of fresh hydrochloric acid, maybe about 50 ml. I'm 4 hours 15 minutes into the reaction. All the gold still hasn't dissolved. I'm going to go ahead and add the remaining 50 ml of bleach. Okay, it's right at 5 hours. I'm going to go ahead and take the solution off the heating and stirring. Let it cool down for a while, settle out, and I'm going to go ahead and try to filter this solution out and then try to dissolve the rest of the gold separately. I'm going to add a few ice cubes, try to cool the solution down so I can filter it. Still quite a bit of gold left in the bottom of the beaker there. I'll have to go ahead and run some more hydrochloric acid and bleach to get the rest of it to dissolve. I'm going to add the filter paper back into the beaker because it looks like it's got some fine particulate gold on it. About 200 ml of hydrochloric acid. Now I'll add some of the bleach to the hydrochloric acid and remaining gold in the beaker. As you can see here, the filter paper will just disintegrate. Any gold that was trapped on the filter paper will be dissolved in the hydrochloric acid and bleach. There's just a few stubborn pieces left that will not dissolve. I'm going to go ahead and cool this off, filter, and proceed with the precipitation with the Copperas. And now I'm going to filter off this second batch of dissolved gold with bleach and hydrochloric acid. I'm going to go ahead and dissolve the last few grains of gold here with a little aqua regia. Add some nitric. Now I'm going to add a little sulfuric acid here to each of the containers to precipitate out any lead that might have made it into the process. And now I filter each of the solutions again. solution's cloudy, so I'm going to filter it back through the same filter paper. Filter it a second time back through the same filter paper. Next, I'll transfer the solution to a large beaker so I can start precipitation with the plant food, Copperas. Here I've got a 1 liter beaker with a ½ liter of hot tap water in it. And I'm going to go ahead and start mixing the Copperas into here. Okay, I've been stirring this on heat for about 10 minutes. I'm going to add some hydrochloric acid here, see if we can get it to green up. It's bright brown looking. There, it's turning green. That's what we want. Okay, now I'm going to go ahead and add some dissolved Copperas here. It's important to filter the Copperas because it does contain bits of iron. If you add it directly to the solution, the chloruric acid solution, then you're going to contaminate it with bits of iron. So it's important to filter. Here's the stir bar where I stirred the ferrous sulfate Copperas, and you can see little black pieces of iron have adhered to the magnetic stir bar. That's why it's important to filter this before you add it to the gold solution. Those magnetic iron bits will get into the gold and contaminate it. I've never really seen this before. Large chunks of gold are starting to precipitate out and drop down into the bottom of the beaker. Pretty neat looking. Something I've never seen before. Big pile of gold flake building up down here. If you can see that or not. Okay, the bottom's got a nice coating of gold over the entire bottom surface of the beaker there. And we got some nice gold foils floating on the top of the solution still. I'm going to go ahead and filter out some of the copper, so I'm going to go ahead and add it right to the solution and see what kind of reaction we get with this filtered solution of coppers. There it comes. There comes the gold. Got dark right before my eyes right there. Do a quick status test here, make sure that all the gold is dropped out of solution. And there's no gold in solution, so we've precipitated all the gold with the Copperas. Okay, I'm going to go ahead and cover the experiment and let it settle overnight, and we'll look at it in the morning. Okay, it's been settling about 6-8 hours now, and I'm going to start out this morning by doing a quick status test, make sure we ain't got no gold going back in solution. And the status test is negative. That's what we want to see. Next, I'm going to go ahead and siphon off the waste solution to my stock pot. Another thing about adding this waste to the stock pot is if there's any gold that comes over with the waste, I'll be able to recover it out of the stock pot. So if I suck some up when I'm siphoning out, it's not a problem. I always make sure I have plenty of copper. I use these copper fittings that I bought off a retired plumber. Got a whole bucket full of them. I always make sure there's plenty of copper in the stock pot to cement out any precious metals. Add a blow two bubbles air through it, keeps the solution moving. Stored under my fuel. Okay, this is what the gold looks like. It's kind of a brownish colored mud in the bottom of the beaker there. Fairly pure. Filter the gold out of the remaining solution in the beaker here. Alright, the gold's been rinsed with some distilled water. Looks like all the copperas has been rinsed out, but watch what happens when I put some hydrochloric acid on it. See that yellow color coming back? Still got some iron in it. Not too bad. I've seen it a lot worse. Now this gold's got a brown color. It's not real caramel colored like I like to see it, so I'm going to go ahead and refine it, give it a second refining. I'm going to start that by putting the filter and the gold right back in the same beaker that we just took it out of. I'm using the same beaker that I precipitated the gold in because there was a little bit of gold stuck to the walls of the beaker, and by redissolving it, redissolving in the same beaker, it'll get all that gold. It'll dissolve that off the walls, and I'll be able to recover it in this second refining. Put it in here on medium heat. And the waste from that last filter operation goes right in my stock pot. Go ahead and add some nitric acid to the second refining to start dissolving this gold again in aqua regia. The fumes inside that beaker will go ahead and attack any gold that's stuck to the walls of the beaker and put it in solution so I can recover it. It's been about 20 minutes and the gold is dissolved. I'm going to go ahead and add some ice cubes to cool it off. Go ahead and add some sulfuric acid, precipitate on any lead that might be present. Go ahead and filter the gold bearing solution with a vacuum assist. Here I'm going to refilter the gold. I'm going to pour it back through the same filter to get the solution nice and clear. Now this solution is crystal clear. As you can see, this is going to make some very high purity gold. Now I'll precipitate the gold with some stump out, which is sodium metabisulfite. Transfer the gold to a nice, clean, pristine beaker with no scratches in it. Go ahead and rinse down the sides of the beaker with some distilled water, and then add some sodium metabisulfite, which I use stump out. I bought it at Ace Hardware. Stump remover by Bonide. Got to get the stuff by Bonide. Spectracide is not sodium metabisulfite. Never get tired of watching this happen. Check it with Stannis just to make sure. And we got nothing in solution there. All the gold's been dropped out. Sodium metabisulfite, which is the stump out. By doing two different precipitations with two different precipitants, we get a nice pure product. I'm going to add the gold and the wet filtered paper to my melt dish over here, and then cover it with some borax. Now I'm going to cover it with a liberal amount of borax, so it'll help keep the paper in the dish when I do the melt. Start the torch. This thing came out real nice gold bar. No traces of contamination. Bright yellow pure gold. And now what to see our weight. What our weight's going to be, I was expecting about 1.5 troy ounces, about 45 or so grams. Ooh, that's 52.1, which is 1.675 troy ounces. Nice piece of gold there. Absolutely pure with no traces of contamination. Probably close to 4.9's fine.